Scientists have long known that the presence of an atmosphere keeps the surface of the planet warmer than it would be without an atmosphere. In fact, without an atmosphere, the surface of the Earth would be about 30 degrees Celsius cooler than it is now. In order to understand why, we need to consider the surface of the Earth and its atmosphere separately. Because there is a radiative equilibrium, we know that the planet emits enough long-wave radiation into space to equal the solar radiation absorbed by it. However, most of the long-wave radiation that is emitted by the planet into space is emitted by the atmosphere rather than the surface of the Earth beneath it. Although the surface of the Earth does emit long-wave radiation, only about 10% of this radiation passes through the atmosphere and escapes into space. The rest is absorbed by clouds and by greenhouse gases in the atmosphere. There are many greenhouse gases, but the most abundant greenhouse gases are water vapor and carbon dioxide. Short-wave radiation from the sun passes through greenhouse gases, but long-wave radiation is absorbed by them. Greenhouse gases absorb long-wave radiation that is emitted by the surface of the Earth. Subsequently, they re-emit the energy as long-wave radiation in all directions. About half of the re-emitted long-wave radiation does escape into space and contributes to the planet's radiative equilibrium. About half of the long-wave radiation emitted by the gases is directed back toward the surface of the Earth. As a result, a continual exchange of long-wave radiation takes place between the surface of the Earth and the atmosphere above it. The long-wave radiation contained in this exchange causes the warming effect known as the greenhouse effect. This phenomena is known as the greenhouse effect because, like the glass in a greenhouse, the atmosphere traps some of the energy beneath it. The greenhouse effect produces a warmer climate on Earth than would be possible without an atmosphere. In summary, water vapor and carbon dioxide allow solar energy to penetrate Earth's atmosphere but prevent much of the long-wave radiation emitted by the surface of the Earth from escaping to space. This trapping of long-wave energy is called the greenhouse effect and enhances the surface temperature of the Earth.